Welcome to this Finland Azure User Group presentation. As you probably already know if you're here already, Finland Azure User Group is the largest tech community in Finland. And we are almost at the 2,000 member limit. Oh, not limit, maybe threshold. So please go to Meetup and join the user group. And these events that we have been having since COVID started pretty much are short 30 to 60 minutes presentations on something that anybody from the community pretty much has learned in the last few months or so. And we have been having these for quite some time now, and today is a really exciting event coming up, at least in my opinion. A bit of housekeeping still before we get started. We will still have 2 more events this year as Finland Azure User Group, one of which is a live event at the Microsoft House. So check out the meetup page for more information about the 9th of December event at the Microsoft House. And the other event we will be having is still another tips and tricks session later this month. I think 30th of November is the date for that. We don't still have the meetup event for that, but I will be creating it later this week. So keep an eye out there as well. But without further ado, I will let our guest today, Azure MVP Joonas Westlin, to take the stage here. And go ahead, Joonas.
Thanks, Pasi. All right, so hello everyone. Today's tips and tricks, we're going to be talking a little bit about the new hosting model for .NET Azure Functions. That is the isolated model. So also during this presentation, if you have any questions, please just post them in the chat. And I do have the chat open actually on my phone here, so I will be able to see them. So I'll just pause if there's any questions. And a quick introduction, Joonas Westlin is the name. I work as a developer / architect at Azure, one of the 7 Azure MVPs of Finland. And I'm pretty active on Stack Overflow regarding Azure. On the bottom left over there is my Twitter handle and also my blog. I post sometimes to my blog. I haven't been posting there as often as I'd like in the recent months, or in the recent year rather, but I'm trying to get back to that as well. So quick kind of overview on what we're going to go through today. Firstly, what the heck is isolate model? And then we're going to look a little bit about the roadmap for Azure Functions, and then a quick demo on the isolate model. And after that, a little bit of the advantages of this model versus the current model. And after that, we'll talk about my favorite thing, I think, about this, and that is middleware. So we have a basic logging middleware, and then a bit more advanced use case doing authentication and authorization functions wide using middleware. Then we'll talk a little bit about the limitations and disadvantages of the model. And finally, we'll have some conclusions and a set of links for you folks in case you want to learn more about what we talk today. So if you make a .NET function today and you don't use the isolate model, you're using the in-process model essentially. So you can see on the right, essentially, we have the one process which is running the functions host. So in the same process, there's the runtime and your functions code as a DLL class library. This imposes some restrictions. You have to use the same libraries as the runtime, for example. So if the runtime uses a specific version of JSON.NET, for example, you aren't really able to choose something else by yourself in the class library. You also have to run with the same .NET version as the runtime, since it is one process. And when you receive a request to this function for like an HTTP trigger, the request data is passed in memory to your DLL, and of course similarly with the other triggers like service bus. Now the isolate model changes this up. It splits the two into separate processes. So we instead have the functions host process like before, with the runtime running there. But now instead of running your code as a DLL in the same process, we instead run it in a separate process as an executable. And the two communicate using gRPC. This was introduced with .NET 5 and is also supported with .NET 6. And this does mean that, for example, if an HTTP request comes, that request data is serialized and passed through gRPC to the executable. So you get a little bit of overhead and certain differences because of that. But what this does allow is that your application can now use different libraries. It can use different .NET version even, doesn't really matter. As long as the process supports that gRPC interface, it doesn't really matter what it's running. And I thought this was kind of interesting because this is kind of the reverse of what ASP.NET Core did with IIS on Windows, since it used to run out of process. And there would be RPC between the IIS process and the .NET process. And then in ASP.NET Core, they moved into an in-process model where the app now runs in the IIS process, essentially. And but it's interesting that we are kind of doing the reverse here. So I took this roadmap from this announcement blog post. You can see the link on the screen there. And you can kind of see there on the top, we have the isolated process, isolate model, and on the top we have the in-process model, on the bottom rather. And you can see there that the isolated process is basically the future for Azure Functions. So the .NET 6 version, which was released yesterday, is the last functions version essentially to support the in-process model. And we'll talk a little bit more about the limitations of the isolate model towards the end. But you can see here that only the in-process model currently supports durable functions. So in case you are using durable functions, you cannot use the isolate model yet. All right, so no questions yet in the chat. So I can go to the first demo. So I'm just going to go to create a basic Azure Functions app here in Visual Studio. We're just going to call it Function App 3. That's fine. And now critically, from here, we are going to choose .NET 6 isolated. And we're going to use the HTTP trigger. That should be fine. And let me just pull that up on the screen that you are seeing. And this is what we get by default. This is the hello world, essentially, for isolated model and the Azure Functions. So the major big difference that you're going to notice is that we have a program.cs file. Because this is an executable. this is something that the functions runtime is going to actually run. And this does mean that you have way more control over what happens during startup. So if you want to set up certain things during startup, you can. And this is actually using the generic host builder that ASP.NET Core also uses. This just uses this configure functions worker defaults, and that's going to, for example, is going to enable the gRPC support there. And another big difference is that if we look at the dependencies for this app, you'll notice that we have a functions library, we have a functions SDK, we have extensions.http, but notice how all of them have the word worker in them. So that's a big difference between the isolated model that all these functions libraries, they have this worker word in them. That's how you can recognize that those are for that. And if we actually run this this project, run this under the debugger, you can see a few things are happening here. So firstly, there it's saying that the .NET Worker was initialized in debug mode, and it's waiting for a debugger to attach. So because it's starting a separate process, there's a little bit of stuff that it has to do to set up the debugger. During the preview for this model, you had to do all of this manually. So you had to start the project, and then you had to attach to the specific project ID, process ID rather, in Visual Studio manually. And yeah, it was a bit difficult, but now it's at least supported directly by Visual Studio. You can also see it's setting up the this kind of event stream here, the communication between the runtime and your process, essentially. And we have this endpoint here, so I can actually just take that. And we'll see welcome to Azure Functions. So that's essentially all it takes now to get it up and running. So not much has changed there, on the surface at least. So some of those big advantages of this model is that even if the functions runtime was running on .NET 6, let's say, you could run your functions app on .NET 7, as long as of course, the functions libraries support that. That are there, but it doesn't really have to be the exact same version. You also really cannot get into library version conflicts with the runtime anymore. You get full control over the application startup. And the big one for me here is middleware. So those of you who have been working with ASP.NET Core, you might know what middleware are already, and they're very similar here actually. Except of course, instead of handling just HTTP requests, there are all kinds of requests that a function might receive. You could get service bus messages, you could have a storage blob updating. So there's a bunch of these different kinds of requests that you can essentially get. So a middleware that you set up or that is set up there will intercept all the requests to all of the functions. And that's where you can handle cross-cutting concerns like logging, authentication, authorization, transaction management, things like that. And now each of those middleware can actually inspect and modify the request data. So you can see on the right there that you can see the request is passing through all of them in order before it reaches the function. So each of them can do modifications to that. They can add some things to the request. They can remove some things. And each of them can also decide to short circuit the execution and just decide not to continue. So if the custom middleware here in the picture decides that, hey, this request is not valid, for example, it can just say like, okay, set the HTTP status code to 403 and just return a response. So it will just never go to the function code at all. So it's up to the middleware to decide if it wants to continue the execution. I've also added into the picture the two default middleware that the SDK itself adds. There's the output bindings middleware and the function execution middleware. But what those do under the hood is not super important for this presentation. So let's look at middleware. And so the first thing that we're going to do is set up a basic logging middleware over here in the Hello World function app that we just made. And the way we do that is that we use a different overload of this function here. We instead use one that takes a kind of a builder there. And what we can then use is say use middleware. Then we just give it the type. So I'll just call it logging middleware. And I should probably note at this point that this is also where you can set up the service. Like around here, you can essentially also set up the service provider. So you can set up all the services for dependency injection. You can set up your logging providers and the configuration sources, all the things like that. But we're just going to focus on the middleware right now. And I'm going to just put the middleware here in the same file so that you can see how kind of how these two connect. Normally, I would make this into separate files. And now it's giving us an error. And that's because the logging middleware is not implementing this interface, iFunctions worker middleware. And this is actually a big difference to ASP.NET Core middleware because there we actually don't have an interface. The reason for that being that in ASP.NET Core, you can just define dependencies in the invoke function. You can just say that I want an entity framework database context as a parameter, and that works. But that does mean that we can't exactly have an interface at that point. But here, because you can't do that, we actually do have an interface that defines the shape for our middleware. And something that we're going to do here is because we need to do logging, well, we need a logger. And the primary way in which you do that in the isolated model is that you call get logger on the function context. And I mention about this to coworkers quite often, but the new Visual Studio's IntelliCode is kind of cool. Like the fact that it just kind of guessed what I wanted to write, and so it's just tab and done. And so I do need that logger here so that I can actually use it. So the only thing that this type is here going to do is it's going to set up the kind of the category for the logs. It's essentially just going to take this class name and make that visible in the logs. Not sure if the functions console logger is going to make it visible though. And the other thing that we get in addition to this context is we get this delegate here to the next function. And the only thing that does is it's a function that we can call, and we just pass the context. So doing this essentially is going to execute our function. If there was another middleware after this one, then this next call would execute that middleware. It's just saying that continue the pipeline. Now, it doesn't actually return anything. The response, the result of the execution is actually in the context after that. But since we want to do some logging, we can actually do that here. So we'll just do some information level logging. We need a method for that. And we're going to just say something like log executing function. Now, Visual Studio is also complaining to me now because I haven't passed in the function name. And we can actually get that from the context. Does that function exist? The IntelliCode was guessing a function that does not exist. I kind of thought so. But I think that is actually correct. So function definition.name. So you can get the function definition from here. So this allows you to inspect the function that is about to be invoked. So there's the name, and then there's this kind of unique ID for it. And we have the output bindings. You have the entry point, which is the fully defined name of the method. There, then we have the input bindings as well, and the parameters. So in case you need to do something fancy that is dynamic based on the what the parameters and or attributes on the method or anything, you can totally do that. And I'm just going to copy this one, and I'm just going to put it after the function here. So we're just going to log executing and then execute it. So I'm actually going to add a debugger here, or rather some breakpoints. And we're also going to go to the function and add a breakpoint here. And we should be good to go. So I'm just going to start the function up again. It has started, and there it is. So if I just refresh this function one here, we can see that we've hit the breakpoint in the middleware right now. So we are going to be calling into this function. You can see here it's function up3.function1.run. That's the function we're going to be calling. We can see that it has one parameter, which is called rec, and it is of type HTTP request data, for example, and the name is going to be function1. And if I click continue, we're going to have just hit this one. And now when I click continue, we're going to be inside the function. So you can see that when you call next and awaited it, we essentially just ended up inside the function. So if the middleware decided not to call next, then this just wouldn't happen. If I now click continue, you can see that now we are after that, we are back in the middleware. So you can see that the response is coming backwards through all of the middleware. And we continue again, and that's done. And we get our response. And you can see here also in the console window that we have this log executing function1. Then we can see the logging inside of the function. And then we see the final one that says executed function. So we essentially wrapped the function using the middleware. No questions though. I see my YouTube has reverted to top chat. That's kind of fun. It just did by itself. But let's go to the more complicated middleware case. And so this particular sample here actually is available in my GitHub. So, and there will be a link to that at the end of the presentation. And what I have in this particular sample is I have a program file, which is very similar to the previous one, except that this time we have two middleware. We have authentication and authorization. Now it's important that we do this in this order because the order matters. We have to execute authentication before authorization because, well, if we do authorization first, it's just going to reject every request because we have not authenticated yet. And the authentication middleware, what it does is it sets up a bunch of stuff to do JSON Web Token validation. And then what it does in the actual invoke function is it gets the token from the request headers. And if it can't find one, it's going to set an unauthorized response and return. If it's unable to read the token, it's malformed, then it's the same thing. And then here, if it is unable to validate the token, and that will be here in the exception handler, since that's how the validate token function works, we know that, okay, this is like an expired token or the signature is not valid or something else, then we'll return unauthorized as well. However, if we do have a valid token, we get a claims principal and we set up a feature in the function context. So features are just kind of, it's a collection of data for the request essentially here. And that felt like the natural place to place this. And so we have a custom class there, which just takes a claims principal and the token itself. The token is put there as well in case we want to use OAuth, some OAuth authentication flows that require using the token that you received as well. And we see here that there's the call to the next step. And in this case, that's going to be the authorization middleware. Now, this sample is based around Azure Active Directory for authentication, but it could be modified for any identity provider. But this is a very Azure AD specific implementation, especially for authorization. And at a high level, the invoke function is pretty simple. We get that feature object that we set up in the authentication middleware. And if we fail authorization, set up forbidden status code and return. That's it. And if we got here, it means that we are authorized and the call can continue. And this is something that I think is going to be best left for you folks to look into more deeply if you are interested. But essentially in this sample, we've set up a custom authorized attribute. This is not part of the SDK. And we are able to just tell it which Azure AD scopes and user roles and so on are allowed to call these functions. So we're able to say that at the class level and also at the individual function level. So in case you want to do something like this, it's quite possible. Now, there's this all looks very nice. that is until we look at this function context extensions file, which, yeah, it's so a couple problems with the current SDK that I've had, or the current libraries, is that, for example, to set the response status code, well, all of the types and all of the methods that are used for this are marked internal in the SDK. So I've just done some reflection magic to say that no, they are not. They are now public, and I'm going to use them. So you can see that, for example, we have to create this gRPC HTTP response, and yeah. So this is really, really kind of terrible because, of course, if they change the namespaces or change the class names or anything, then this all just stops working instantly. But of course, the good thing about that is that because this is part of a DLL that's bundled with your app, you're probably going to notice that if you update the runtime, and then would be just this one place that you have to fix, and then you're done, essentially. So it wouldn't be too much of an issue, but I do wish that this was better supported there. And I think we can actually try to call these functions as well. I'm going to just open up Postman. I'm going to just set up request here. So it's going to be the only scopes endpoint, and for authorization, we are going to get a new access token here in Postman and use the token. Okay. I'm actually going to make this a little bit smaller so that you can see the functions window as well. So if we call the only scopes endpoint with my user's access token, it should succeed. And yeah, it does. So we get a 200 OK, and we get a text response. And we also can see that over here. So we see that it was executed and it was successful. And now if we try to call the only admin endpoint, and so the only difference between this endpoint is that this actually requires the admin user role, which my user doesn't have. So if I now send it, we get a 403 forbidden. Yeah. So we have authorization, which is working. Now, one thing is, of course, it still reports it as succeeded because, well, I mean, it didn't crash into an exception. So it is a success from the function's point of view. This could use some logging for sure. Okay, so a little bit on the limitations and disadvantages of this model. So like I mentioned before, durable functions is not yet supported. It will be in .NET 7, according to the roadmap at least. And then, of course, supported from then on out. And this does have a longer cold start. So in case you don't know, Azure Functions has this issue with cold starts because it is able to scale to 0 instances. And of course, then it's going to take some time for it to get an instance for you and then get it up and running. And this is a bigger issue with this model because now it actually has to start up another process as well, in addition to that main process. This is apparently better in the Linux consumption plan. I haven't tested this though, but that is what they say in the GitHub wiki at least. They are planning to improve that though. And of course, you can get better cold start if you just use the Azure Functions premium plan. I mean, you know, who knew? Just pay more and it'll work better. And then there's also the issue that certain bindings don't work or that they work differently. For example, in the kind of current in-process model, you can bind into certain SDK-specific objects, like with service bus triggers, you can bind into brokered message objects. But with this, you can't because these are passed over gRPC. So it's going to be some kind of function-specific object that's going to be passed. and not something SDK specific. And that's partially a good thing, because it means that they are not going to be tying you to some specific version of the Service Bus SDK, for example. And then there's just cases where some things just don't work. And we can actually look at those in a bit as well. There is this differences with .NET Class Library Functions section there in the first link. There's the known issues page in the wiki. And Sean Feldman had a blog post as well where he was trying to send multiple service bus messages as output, and that was not like directly supported there, but he managed to do it, and he's sharing his approach there. So that as an example of something that you might have to do differently. So we are essentially at the end, a little bit early, I suppose. But we'll have some time for questions, and we can also look at the pages there a little bit. And well, as you saw in the roadmap, this is the future for Azure Functions, for .NET Azure Functions. And you can use this today with .NET 5 and .NET 6. And of course, if you are currently using the in-process model, you don't need to worry. That is supported on .NET 6. And since .NET 6 is a long-term support version, it's going to be supported for a couple of years. However, once .NET 8 comes out, you would be needing to migrate at that point. There's a lot of advantages that I think the isolate model provides, but there are disadvantages as well, and you'll have to consider those if you have an existing functions app. And I would kind of recommend that you first update to .NET 6 if you are using in-process model. Just first do that, and then do the isolated model migration. So don't do those two at the same time. That might be not a great experience. And I'm hoping that some of these issues that we have will be ironed out for .NET 7, but I guess that is something that we'll see. And here at the end, I have some links. So the first one is to the main guide for the isolate model. Then Mark Heath has a post on the isolate model as well, which is great. And then there's the roadmap link that was earlier as well. And then there is the link to the announcement that Azure Functions v4 and .NET 6 support are generally available. That was published, I think, yesterday or the day before yesterday. And yeah, it also mentions, also talks a little bit about the isolate model there. And then there's also the link to my sample application, which authenticates the JSON Web Tokens and does authorization against them.
Yeah, while we wait for questions in the chat, do you know if there are kind of performance differences between these two models other than the cold start? I would guess that probably not, as the process is already running, but still.
Well, I would say that there is going to be some overhead since the functions runtime is going to have to serialize it over gRPC. So there is definitely some overhead. It will probably affect somewhat, but I don't think it's going to be a major effect. I think it's going to depend on the scenario. And actually here on this page, you can also see some of those differences between the in-process and the isolate model, which they call out-of-process here. There's, for example, out parameters are not supported, cancellation tokens are not supported. What else? Durable functions is not supported. Yeah, but then there's that middleware not supported in the in-process model, but supported in the isolate model. But there is that, the longer cold start.
All right. We had one question in the chat but it's actually the same question that I just had. So
yeah, that is that one. So I haven't measured anything. I haven't done any kind of performance measurements, so I can't say how big the hit is at all.
Right. If anybody has still any questions in the chat, put them there. And after this presentation, we will add the links to the description of the YouTube video also. But other than that, if you were starting a new project right now, would you kind of prefer using the isolated model directly from the start, or is it still kind of case-by-case basis on your end?
Well, you would have to consider the limitations for sure. So you would have to consider which kind of triggers, what kind of outputs you want, and then check those if those are actually going to be supported before going ahead with it. But if it is okay, then I would definitely go with the isolated model right from the start to avoid the migration later.
Yeah, sounds reasonable.
But yeah, existing functions apps, just updating to .NET 6 is definitely a valid choice. And then leave the isolate model migration for later, especially if you are using something that is just not supported.
Indeed. Let's still see if there are any other questions in the chat. Currently no. So I suppose we can end this session for now, and you'll have the links to contact Joonas via Twitter and other channels in the description also after this presentation, so feel free to check them out there. Thanks, Joonas. I think this presentation at least made it more clear to myself on what the actual differences are between these two models, because I feel that previously they have been quite, or they have needed some user effort to actually dig them up to understand what the differences are in general. But other than that, thanks, and everybody feel free to check our meetup also for the future events.
Yeah, thanks everyone.